All right, so next we'll look at this idea of a complex number. So the reason we started with imaginary is that, that complex numbers involve both an imaginary part. This bi part is our imaginary part, right? That's I means I, and then some number b, and it gets our real part as well. So if we look, our real part is this I, right? So it has two pieces. That's why we call it complex. So you could have anything from, let's say, 3 plus 2i. That tells us that we have 3 in terms of real and 2i in terms of imaginary. Sometimes you'll just see, let's say you just see 5i, right? So that just tells us we have an imaginary portion, but our real portion is not part of this term. So that's a brief little idea of what a complex number is. It's combining a real number and an imaginary number, because even if we look over here at 5i, we could still say plus 0, which is real. So this is going to take us into our arithmetic for dealing with imaginary numbers and complex numbers. This should look pretty familiar, although instead of x's, now we have i's. So we've got to think about what we should do when we have i's. This should be going back from quite a long time ago, thinking about adding and subtracting if we're talking about like terms, right? So a keyword here that we're thinking about is like terms. So when you think about like terms, you think, okay, they have to have the same variable and same exponent in order for you to combine them. So in this case, we can kind of think of these i's to tell us what terms are like terms, right? So they both have i's, so we'll be able to combine those by adding or subtracting. Then we can also see that we have terms with no i, so those are our like terms. So first we want to look at adding 3 and 7. 3 and 7, hopefully you see 3 plus 7 gets us 10. Then if we go ahead and look at our imaginary portion, we have negative 6i plus 12i. So negative 6 plus 12 gets you to positive 6i. And it's the furthest you can go because you can't combine something with an I and something without an I. All right, next let's look at when we're looking at two binomials. So here we have two different binomials, right? Sometimes you might have an addition, sometimes you might have a subtraction. And so let's go through and first label our like terms. So we see we have a 3, we have a 3, and we have a 4. Neither have i's. Then we have to go to our things that do have i's. So we have a 2i, and we have a negative 5i. And so since there is an addition in between these two, you can kind of just go straight through dropping the parentheses. And if we want to combine our non-imaginary, our 3 and our 4, we get to 7. And then if we want to combine our imaginary like terms, we've got 2 minus 5i. That gets you to negative 3i. And we're done at that point because we've combined all the things that have i's and all the things that do not have i's. Lastly, we're going to move on to when there's a subtraction in between. Again, we should go through and say, all right, what's my like terms? Here's a like term. Keep forgetting to switch my pencil. Here's a like term. Here's a like term. Here's a like term. Here's a like term. All right, but now we've got to think about, okay, what happens when there's subtraction? Hopefully some of you are thinking, oh, just distribute that minus. Distribute that minus. So if we want to rewrite, let's say, we rewrite, we get 2 plus 4i, right? That did not change. But then if we distribute the minus, we get plus 1, and we get minus 4i. So here we can say, okay, we've got a 2 and a 1. We add them together, we get 3. We've got 4i minus 4i. What are we left with? Nothing. They cancel each other out. And so our final answer here is just 3. Notice we started with some imaginaries, but we ended up with just reals, no i's.